Before we begin talking about like terms, we have to talk about some basic algebra words. The first word is variable. Now, the word variable basically just means an unknown value. And so in math, we usually let a variable be represented by any letter of the alphabet that you like. Most of the time, you'll see the letter X or N, but it can be any variable. Any variable can be any alphabet letter that you want it to be. Alright, a coefficient is a number that's multiplied with a value. So it's usually like the big number that's out front. So if you see 2x, the coefficient would be the 2 that's out in front of the x. Or if you saw 7x squared, the coefficient would be the 7 because it's the big number that's out front. Alright, the word term can mean either a variable, like x, a plain number, like 4, or a coefficient and a variable, like 4x. So any one of those would be an example of a term. Alright, so let's talk about like terms. So in order for two terms to be like terms, they must have the same variable and they must have the same exponent. Now the exponent is the tiny number that your variable is being raised to. So like if we had 4x to the third, our exponent would be 3. Our coefficient, which is our big number out front, is 4, and our variable is x. So an example of like terms for 4x to the third would be like 5x to the third. Now notice that these two terms have the same variable. They both have x as their variable, and they have the same exponent. They both have 3 as their exponent. But notice how the coefficients 4 and 5 are different. That's okay. It's okay if they have the different coefficients, but they have to have the same variable with the same exponent. Another example would be like 6x squared. 6x squared's like term could be 9x squared. The only thing that they have to have in order to be like terms is they have to have the same variable, which they do, with the same exponents, which they do. It doesn't matter that the 6 and the 9 are different. Now, what if we had x to the 4th power? And then over here we had 4x. Now, x to the 4th power and 4x are not like terms. They're not like terms because x to the 4th has an exponent of 4. And over here, 4x has an exponent of 1. If there is not a number that a variable is being raised to, it's automatically a 1. So notice how 4 and 1 are different. So these two would not be like terms. Alright, now let's talk about the distributive property. So the distributive property is just multiplication used to get rid of a set of parentheses. So notice how in this problem we've got 2 parentheses x plus 1. Now, whenever you have a number and a set of parentheses written side by side, the first thing that you want to do is get rid of the parentheses. Think of parentheses as being bad. Whenever you see them, it's more work for you and you've got to get rid of them. Now, in order to get rid of the parentheses, all you have to do is multiply. So the number that's out front needs to multiply everything that's inside those parentheses. So you're going to take 2 and you're going to multiply it by x and you're going to multiply it by 1. So whenever you multiply 2 times x, you get 2x. And then when you multiply 2 times 1, 2 times 1 would just give you 2. So your final answer for this would be 2x plus 2. Another example, we've got 3 times x plus 4. So the parentheses mean that I need to take this number that's out in front and I need to multiply everything that's inside the parentheses by that number out front. So this means I'm going to do 3 times x, and I'm going to do 3 times 4. 3 times x is going to give me 3x plus 3 times 4, which gives me 12. So my final answer is 3 plus 12. 3x plus 12, excuse me. Now in the second example, I've got 2x minus 1, parentheses, with a 6 on the outside. Now just because the 6 is at the end of the parentheses doesn't mean we have to do anything different. Remember, if you see parentheses and a number written directly beside it, not separated by anything, that means you need to multiply the number on the outside by everything that's on the inside. So just like I did on the first example, I'm going to multiply 6 by everything that's on the inside of the parentheses. So that means I'm going to do 6 times 2x, and then I'm going to do 6 times negative 1. Now 6 times 2x, that's going to give me 6 times 2, which is 12, and then I'm going to slap that x on it. So 12x. And then I've got 6 times negative 1. So that would be plus 6 times negative 1, that would be a positive times a negative, that would be a negative, and 6 times 1 would be 6. Now if I wanted to write this to look a little nicer, I would do 12x minus 6. Now number 3 looks a little different. So number 3 says negative parentheses x plus 5. Now this one doesn't have a number out in front of the parentheses, but I know if there's nothing there, there's an imaginary 1. So really, in front of or behind this minus sign or this negative sign, I have a 1. So really, I'm going to distribute negative 1 to everything that's inside those parentheses. So I'm going to have negative 1 times x plus negative 1 times positive 5. Negative 1 times x is going to give me negative x. Remember, a negative times a positive is a negative, and 1 times x is x. Plus negative times a positive, that's going to be a negative, and 1 times 5 is going to give me 5. If I wanted to make this one look nicer, I would say negative x minus 5. Now sometimes you're going to have to use a distributive property to solve equations. Remember, the difference between an expression and an equation is one can be solved. An equation can be solved for your variable, and it always has an equal sign. What we've been dealing with so far in this video have been expressions because they did not have an equal sign. Now, whenever we're solving equations using the distributive property, we have a few steps that we have to follow. The first is we have to distribute the number out front. So remember, whenever you see a parenthesis, set of parentheses, there's really a number out front. If there's not a number there, it's an imaginary 1. But in this case, we have a 2 out front. That means we're going to distribute the 2 to everything that's inside the parentheses. We don't have to distribute the 2 to the 28 on the other side because it's not in the parentheses. The only thing that we're distributing by 2 is the stuff inside. So 2 times x and 2 times 7. We're still going to have it set equal to 28 because it was originally. Now let's make it look nicer. So 2 times x is going to be 2x plus 2 times 7. 2 times 7 would be 14. So now we have 2x plus 14 equals 28. Now we want to combine our like terms. Now, our like terms in this case, we don't have to do that. We don't have anything we need to put together. So now we're going to solve for the variable. That means that we're going to solve for our x. That means we want to try to get this x by itself. To get x by itself, we need to get rid of everything on the left side that's not x. The first thing that I see is we need to get rid of that plus 14. So in order for us to get rid of plus 14, we have to do the opposite of what it says. So we're going to do minus 14. So we're going to subtract 14 from both sides. When we do that, the 14s will cancel, and that will just leave us with a 2x on the left side. And 28 minus 14 would give us 14. So now we've got 2 times x equals 14. But remember, we're trying to get x by itself. So we want to do the opposite of what our problem tells us. Right now we've got 2 times x. To do the opposite of 2 times, we would have to divide by 2. When we divide by 2 on the left side, the 2's will cancel, and we'll just get x equals, and on the right side we'll have 14 divided by 2. 14 divided by 2 would give us 7. So we find out that through all of this, our x is equal to 7. Alright, on our next example, we've got 3 parentheses, x minus 1 equals 12. The first thing that I notice is that we've got parentheses. Now to get rid of the parentheses, we need to distribute the number that's out in front of the parentheses. So when we distribute, we're going to multiply everything that's inside the parentheses by the number that's on the outside of the parentheses. So this is going to be 3 times x plus 3 times negative 1. And remember, we still set it equal to 12 because that's what it was originally. So 3 times x, that would give us 3x. And we've got a positive 3 times a negative 1. That would be a negative. Remember, a positive times a negative is a negative. And 3 times 1 would give us 3. So we have 3x minus 3 equals 12. Now, our goal is that we want to try to get this x by itself. So we have to get rid of everything on the left side that's not x. The first thing that we have to get rid of is the minus 3. Now we have to do the opposite of what minus 3 is. The opposite would be plus 3. So we're going to add 3 to both sides. When we add 3 to both sides, the 3's on the left side will cancel, and that will just leave us with 3x equals 12 plus 3 on the right side. 12 plus 3 would give us 15. So now we've got 3x equals 15. We need to do the opposite of what the problem says. It says 3 times x. So we have to do the opposite of times 3. We need to divide by 3. So we divide the left and the right both by 3. The 3's on the left will cancel, and that will give us x equals 15 divided by 3 is 5. So we find out that our x is equal to 5. Now if we wanted to check our answer, we could take our x equals 5 and we could plug it in for our x. So this is a good way to check and see if what you did was right. So this would be like 3 times 5 minus 1 equals 12. Notice I just took the 5 that we found out was x and I plugged it in where x was. So we know that 5 minus 1 would be 4, and we want to make sure that what we have on the left is going to equal what we have on the right. So what we want to know is, does 3 times 4 equal 12? 3 times 4 is 12, so that means that 12 equals 12, so we got it right.